Hello, everyone. We are just going to give it a couple minutes for people to jump on, and then we'll jump into today's webinar. Awesome. For the people that have just joined, we're just giving it a minute here, letting people hop onto the call. And then in a minute or so, we will dive into our webinar with Maya HTT and our lovely Remy Duquette. Perfect. Why don't we hop in? So hello, everyone. I'm Nicole Rathie. I run AI for Manufacturing Canada. We are an organization focused on connecting AI companies and manufacturing companies in Canada to really get educated, to adopt technology, and have these conversations like we're going to have today about where to start, where to go, the use cases within the ecosystem. So today I am excited to welcome you to our webinar, Leveraging Generative AI to Expedite Troubleshooting and Document Search in Manufacturing. A quantitative analysis from Maya HTT about MBOT clients. And so today we are joined by Remy Duquette, a Vice President of Innovation and Industrial AI at Maya HTT. The man has a million awesome qualities and a ton of experience. So I will pass it off to Remy to introduce himself because I probably won't do it justice. And we can jump into today's webinar.
Thank you so much, Nicole, for the introduction, and welcome everyone to our nice discussion today on leveraging large language models in the manufacturing environment. As Nicole mentioned, my name is Remy Duquette. I'm the Vice President of our Industrial AI practice at Maya HTT. Maya HTT has been a Canadian company headquartered in Montreal with offices across Canada, US, UK, and France. And we've been in business for 40 years. Our entire focus is in engineering, manufacturing, and AI and operational technologies in general. Our group has helped 150 plus clients to leverage AI technology specifically, plus 5,000 other projects and clients in other areas. Again, all centered around engineering and manufacturing. We're the #1 Siemens value-added reseller worldwide and an Aviva premium partner and certified Azure and NVIDIA partners. So from that perspective, I think you can see that the complexity and understanding the physics behind the data is really where we centered our effort and where our value add is for clients like you who are probably looking for partners like us to move forward in a smart way using new technologies in the field. Before I launch into the large language model and how to leverage it using MBOT for your industrial troubleshooting and manufacturing shop floor workers, just wanted to give you paint a little bit of a broader picture of what Maya can achieve with you and for you. We have a fairly nicely distributed engineering tools and solutions that we can bring to bear to help you either early on in your manufacturing cycles or downstream in terms of your operations, whether it's the shop floor operations or the industrial operations with heavy equipment. Anything related to what I call dirty data in the end, because that's the world we live in, is where Maya can help you and augment your existing team or your existing processes. We target about 12 different industries. You can probably see yourself in one of the either heavy machinery, mining metals, manufacturing of various products and components here in food and bev or oil and gas or pulp and paper or marine industry. Or energy. We've launched recently also from an eco-friendly geothermal industry, specific applications. You can see, some of our world-class customers here in the 12 industries that we target and support and service. And hopefully you can see that we augment the best of companies in the world. And hopefully you're next on that list here of nice logos. With Nicole and the AI for manufacturing in Canada, we focus a lot on use cases. So before, again, I launch into large language model, I wanted to show the focus of Maya in those use cases and helping you understand how machine learning, AI, and various technologies, operational technologies, can help you from a digital transformation perspective. So we deem it like the Epic M kind of model, where we start with E, which is anything related to energy efficiency is where we can add value. Productivity improvements, yield, throughput, OEE type of raw material waste, at startup time. These are the use cases that we focus on. Inventory, costing, forecasting. We'll see some of the relationship here with LLM down the stream, but with quality improvement and maintenance improvement. Again, all kind of useful components and places where you can start your journey in leveraging new AI technologies. When you start, yep.
Sorry to interrupt. We've just had 2 people in the comments say they can't see the presentation on the screen.
I can reshare my screen.
If the attendees could let us know in the chat box if you can see the presentation. I can see the presentation, so unfortunately, maybe I'm not a good test sample. Okay, so I think we have a mixed bag of people being able to see it and some people not being able to see it.
Okay, well, in any case, there will be the recording available for you. So I'm sorry if you have challenges with the connectivity or whatever it is, but in any case, it will be available through the recording. So when I say about, when I talk about those Epic M use cases, it's very important for you as a manufacturer or an industrial operator to start with your business challenges. So before you take the magic, wand of LLM and trying to, implement some AI, or whether it's LLM or deep learning or anything, you really want to start with your business challenges first, and then apply it to the various areas and move around along the maturity curve of where you are, and be very frank with yourself as to where you are in that maturity curve, right? If you need additional sensors, leverage data, put data systems in place, well, start your effort there, and then slowly move up the food chain, towards prescriptive type of AI control and machine learning projects down the stream. So that's the way that we see it with our client that, have had a lot of success over the years. So if you look at the success, from a proven track record, 150 plus AI projects deployed, adopted in real industrial manufacturing environments, harnessing up to 5.7 million sensors and telemetry points and other components, and leveraging various mix of on-premise operational technologies, edge devices, and sometimes cloud solutions. So a mix of these components. If you look at some of our use cases and clients, you see here in the pulp and paper industry, using 600 real-time telemetry components for predicting 20 quality parameters in real time, instead of every 5 to 15 minutes with quality samples and clipping of piece of paper, which was what they were doing before. We implemented a data-driven solution and an executable digital twin solution. Here you can see more of a manufacturing of lower volume production, where you see composite parts for aircraft components being manufactured. And again, here the importance of the use case is we reduce the amount of defects but we also link the defects with their root cause and what caused that defect in the first place. If you look at lithium batteries for electric cars, in this case, the manufacturing and deep learning helped with 10 hours of productivity reduction in the cooling time and savings in the raw lithium. So again, very specific business use cases. A lot of people ask, how do I know that AI is actually helping? Well, if you can see here in the signal itself, for the control volume of the components that was actually measured, you can see that as soon as we enabled an AI component, you can see how better the control becomes. And then over time, that means for all the parts, the mechanical parts in the systems, they get less strained. So the parts lifing gets extended, and you get reduced amount of unplanned maintenance and even, longer time frame for your maintenance between maintenances, which you save costs on the back end. But really, that's really how you can visualize it. We've done it for very large fleets of industrial equipment, like in this case, shipping companies that are shipping goods around the world. In this case, CSL, we can mention their name because we had a public presentation of this use case with them. We built with them more than 1,000 smart anomaly indicators to help them better make better decisions, data-driven decisions. Now, today the focus is not on those use cases, but that was to give a kind of a background as to why we built an LLM and leverage, the documents that are there for troubleshooting on the shop floor. Because we've seen a lot of challenges on the shop floor as we were deploying these other type of AI techniques and models. So first, let's set the stage of what the problem is that we were trying to solve. So a lot of people are asking, where's the textual data that I need to do my job, right? Where's the troubleshooting guide? Which page is the information to help me troubleshoot this component? Even if you know where the document is, how quick can you get to the information within that document? Often people are faced with this kind of splash. I mean, this is, of course, an analogy of a big board with lots of information on it, right? And so where is that information? It's not easy. If you look at engineers and manufacturing people in general, what do they need access to? Well, access to a lot of various, very technical type of information, which by default, and in a large language model like ChatGPT and others have a baseline for, but don't have your specific data for your specific process, for your specific machine or industrial equipment that you are operating. So really, the amount of information field is very vast, and the textual information in technical drawings, in troubleshooting guides, in engineering manuals, all of that information can be leveraged, right, to answer a specific question. So that's really where we started looking at where is that information? And a lot of people asked us, well, can't I just use my PLM or MES system or ERP system or SharePoint to find that information? Well, in some cases, yes, right? Some cases, those tools are still very valid, very useful, for very technical CAD, 3D, component documents that you want to visualize. Yeah, this is still the tool, the right tool for the job. When we want to answer questions in a chat-like manner, right, that combines a lot of information across these different types of documents, that's where it falls short to answer, and it falls short to answer it in a timely fashion for you to use that information, right? So that's where the evolution of large language models, is actually quite amazing for us to leverage from a manufacturing viewpoint. Now, just for everyone on the call, in 2017, there was let's call it a triggering paper called Attention is All You Need. That's on the research side that came out, and that laid the foundation for everything that you saw afterwards. And, people mostly woke up to the ChatGPT version 3.5 coffee, but there was a lot of other instances of large language models prior to that. So that's what I'm showing here in terms of the timeline and the efforts that went into building these large language model. Maya, as an AI company, we, in the manufacturing world, we were aware and followed, right, the evolution of these. Of course, we don't have the bandwidth of OpenAI or Microsoft or Google to build a base model, but we have the power and the expertise to build on top, right? And that's what we're going to present today. Some of the LLMs, just in terms of concepts, LLM stands for large language model. The parameters are typically what we call pre-trained transformers. So transformers is what I talked about, in 2017. Attention is all you need. That's when these new techniques were essentially perfected from a research standpoint. But we're talking about very, very large neural networks, right? We're talking about 175 billion parameters from a GPT-3, the original one. We're not talking about the ones for today. Then there's GPT-4, which was trained with what we call RLHF, reinforcement learning from human feedback. So again, bringing additional precision and accuracy in the way that the text was formulated. And now more recently with the 4.0 access to current data and live browser data is kind of bringing it to another level. So all of these key concepts are important for you to understand in terms of the baseline. The limitations is often, the language model needs to be understood that it's not a truth model. It's really a language model. So it will, look at the frequency of data in terms of the text, right? What came next in from a probability standpoint if you ask a certain question, and what are the sequence of words and sequence of paragraphs that should follow. And so once you start down a path, it will just outline or chat with you in a very convincing way, but it may not be the truth, right? It's just the next best logical word or best logical sentence that follows, right? So people have deemed hallucinations as one of the key problems in the early days of ChatGPT that would hallucinate things, right? Make up stories that really didn't exist. So that's a little bit problematic when you want to use it in manufacturing, right? So you don't want the LLM to provide a sort of good answer, but not the truth, not the right answer to your technicians, because that could lead to disasters, right? So from a Maya perspective, when we looked at leveraging LLMs, the first thing we thought, okay, it's like we need to fine tune it and safeguard, right, the answers so that it actually has a truth backing, something that we can get back to that could explain the answer from a chat response to your question. So that's what we're going to focus on. Some disclaimers, those were in the early, let's say, going over the last year and 6 months, a lot of these things have slowly resolved themselves, but there's still legal lawsuits and things. So we're keeping an eye on these things. We can't control them, right? We're not building the large language models themselves and the base models themselves. But there are valid concerns on copyright infringement and learning from your corporate IP that we want to address here. So that's really our focus from that standpoint. So, MBot to the rescue. First, the business case. More than 10-15% of the time of your engineers and manufacturing shop floor workers are spent annually in searching for data, searching for the information so they can do their jobs better. So that's roughly half a day a week that you're losing from these very highly skilled people that should be able to, contribute a lot more to your bottom line and to your profit. So if you look at the solution, well, MBot essentially accelerates that search, and we'll see how it does that. First and foremost, because we want to leverage your specific intellectual property, we made MBot runnable locally on your premise. So it can run on one GPU, and after we'll see the next steps. If you want to continue the conversation with me, we can send you the specification of what you need to acquire from a GPU perspective to run your large language model locally and MBot locally without any internet connection, right? So it would never send a query outside your firewall to another large language model and bring back the information. That's not how we have architected this to work, because we did not want your private intellectual property, your private secret sauce, right, so to speak, on the manufacturing shop floor to get out the door. That's been clear from our clients and all our interactions on the manufacturing shop floor. They want to keep their secret sauce secret, which means they want things to run mostly locally or in their private, safely guarded cloud tenant. But again, a private cloud tenant means it still stays within your firewall of that tenant. It does not go outside to a ChatGPT type of equivalent and bring back the information. It stays within your firewall 100%. So that's really what we have put there. In terms of the way it works, not that you are wanting to build what we've built over the last year and a half, but if you look at a client asking a question, so how does this work, right? So that it can run locally on your workstation and not in a cloud environment. So first, we scrape all the PDFs and the text documents that you have access to. So all the troubleshooting guides, all the machine guides, everything that has technical information relevant to answering challenges that your shop floor workers might have, process diagrams with information on the process itself, the manufacturing steps, and all of that. So all of the best practices that you have on your shop floor for operating the shop floor in your manufacturing process, you have those documents somewhere. So we will ingest them locally, right? And then put them in what we call a vector database, which is simply a fancy word to say we're going to compress the information so that it can be readily and very quickly read by an LLM model running locally on your premise and answer any query, any question that your shop floor workers will have in a chat-like fashion, right? So there are multiple approaches to this. Option one would be, as I said, you could use an equivalent with ChatGPT on a cloud-based solution. But again, the caveat there is you are sending pieces of information outside your firewall to another machine that belongs to, in this case, OpenAI, and then retrieves the information, or Microsoft, depending on which vendor you leverage there for the ChatGPT access. And yeah, and so you could use that approach, right? Another approach, which is the one that Maya is focused on, is to remain 100% confidential with your data, meaning that it will never, no text, no embeddings, nothing will ever be sent outside your firewall. It stays within, and it answers and it augments itself based on your specific data. So we've run some qualitative human scoring on roughly 10, scale of 1 to 10, based on a bunch of technical questions, troubleshooting questions, engineering questions. And we asked our engineers, right? And we didn't tell them if they were running GPT or our augmented LLM from Maya, right? To remain 100% clean and clear here. We didn't want to bias our own results. So what we did is simply ask them to score the answers that they were getting from 1 to 10. And here we can see, from a GPT version versus an augmented Maya LLM version, the qualitative scores that you're getting. So for usefulness, GPT-4 got a score of roughly 6.5. Our augmented LLM, NM-bot from Maya, got a score of about 7. On the accuracy side, this is where it gets really interesting because we fine-tune the information on the private information locally. We are able to increase the accuracy of what is being sent. And I'll show an example and a little video of the demonstration of the MBot in the next slide. But just so you see, like the actual accuracy is much higher because it goes down to the document page and gives you the link to that page as well. So let's run a little example here. We ask for technical questions on Teamcenter. It's a technical PLM solution from Siemens. And it gives not only the answer, but the link to the document itself, right? So there were hundreds of documents in the backend database. We ask a question, it answers the question. We can give it feedback, thumbs up, thumbs down, right? If we'd like or not. And it gives the confidence level as to where the information came from. And you can click on it and access the information. So that prevents, any chances of having hallucinations, because you see the reference on the document and you can click on them and see, if it's relevant or not to what you're experiencing. If you're troubleshooting an equipment, well, you'll have the information and the steps in that document, and that's where it will lead to. And this is almost instantaneous, right? You can see here, it's very quick. So that, even if it runs on-prem. So the fact that you can, now have a way to access the information within hundreds of troubleshooting guides that your shop floor workers may or may not know it even exist, right, is really key. And if you think of the shortages in manpower that are kind of predicted or forecasted in Canada, certainly these types of tools here will help younger workers to do a very good job, right? Because they will have access to information more readily, and they'll be able to execute on these steps and these guides that you have and that you've perfected over the years with human beings that knew what they were doing, right? So that's very important as well. So, again, conclusions, very briefly, we leave a few minutes here for questions. We compared, from a privacy standpoint, augmenting the knowledge, control, results variations, usefulness, showed all this. In the end, the on-prem or private cloud version of the MBOT from Maya seems to be faring, much better, because we, leave the information very close to the local LM model, and we perfected the queries and the engineering on how we asked the question also to the LLM and how we asked it to summarize for the answer. So in the end, I think this has a lot of benefits. Plus, we have the link to the end document to me, and that's the biggest value in the end for the actual shop floor workers, is they can access the real information that was used to answer their question. So next step, you can contact us. You can scan those QR codes if you see the screen. If not, you can look at the recording later. We have a Get AI Ready type of document, an AI in manufacturing white paper, if you're interested in reading more about what we do and how we do it. And now, if you want, you can send me an email and I will answer any additional questions. Or if you have questions, I think Nicole can look at various questions and try and trick me into answering.
Most certainly. Yeah, I was just going to say, I can open up the floor. We don't have any questions in the chat box right now, but to our audience, if you have any questions, feel free to pop them in the chat box, or I believe I can take you off mute if you put your hand up or anything like that. Well, one question I had for you, Remy, I think, it's a really awesome tool to see you guys build, and I'm curious as well to kind of, do you see any key industries that are really ready to adopt this kind of on-prem and more secure? Kind of, what are those industries that are leading the way in kind of adopting the MBOT?
Kind of interesting because originally I thought it would be more along the lines of aerospace and defense and automotive in Canada that would latch on faster. And in the end, what we found out is it's pretty widely distributed, whether it's a small metal, a CNC machining shop, or let's say food and beverage company, or even on the marine side. I mean, it cuts across all sorts of various industries. So at the moment, I don't see certainly the core industries that I would have thought would have been leveraging the MBOT first are on par with the others. So, and I think maybe this is due to the fact that people are seeing a large language model as really as a tool to augment their people. And so that kind of cuts across any industry. Every industry has those needs. And because we run on-prem or on private cloud, it kind of gives that confidence that their secret sauce are not going to escape, right? So yeah, but to your question, yeah, we have across the 12 industries that you've seen on our slide, we have cut across, and there's not a dominating kind of industry at the moment.
No, awesome. No, that's, I think, a good indicator to a really helpful tool.
Yep.
One other question I kind of had while listening to your presentation here was, I was curious. I hear a lot of, the manufacturing world has those kind of shop floor workers or engineers that have been in the business for so long and kind of have that knowledge kind of weaved within them, and they're a walking MBot, if you will, sometimes.
Yep.
Does the platform have the ability to also kind of take their knowledge into account, or is it strictly kind of the manuals and the PDFs and the documentation that the company has?
Well, so insofar as it relies on textual information,
Yeah.
if the company has a lot of logging of troubleshooting that their shop floor workers have done in the past, all that information can be fed into the MBot, right? So as long as it's in textual format somewhere, it doesn't have to be like a formal troubleshooting guide. It can be the ticketing system that has all the textual information on the problem and what was done to solve that problem, right? So as long as it's properly documented somewhere, then we can reference to it from a textual perspective. That's really the baseline requirement there. But yeah, we don't have a plug that we can put in the brain of a person yet. So
Exactly, yeah.
unfortunately, until Elon Musk or someone else, builds that
Yeah.
machinery, we will be limited to the textual information. But we've seen some creative ways of leveraging, the older, mature kind of employees' knowledge by running interviews, and then converting the voice to text through voice to text commands, generating a huge wealth very rapidly of textual information based on those interviews of, hey, during describe the worst day in your life in the plant, right, and what you did to get out of this problem, and that kind of open discussion can still be referenced in a large language model from that perspective, from a textual perspective.
For sure. Makes sense. And yeah, I really just appreciated you taking the time today to chat with us. I'll open it up. Those are all the questions I had for for today, but I'll open it up to the floor once more. If anybody has any questions, feel free. Kind of now's your time to shine. If not, we can definitely wrap this up a little bit early today.
Sounds good. And if you're too shy, just send me an email and I can answer to you privately.
Exactly. You just did such a good job of explaining it that there's no questions to be had. So we can wrap that up for the day. Thank you guys all so much for joining us. I will be sharing the recording of the webinar, as well as all the contact information about Maya and AI for M, and the ecosystem that we're building here. So thank you all so much, and hope you have a great rest of your day.
Thank you, Nicole.
See
See
you,
you
Remy.
around, everyone.